So in this problem, we have a jet-propelled supersonic vehicle that's accelerating from 0 to 100 kilometers per hour in a time of 4 seconds. So the first thing we're going to do is convert 100 kilometers per hour into meters per second. And in order to do that, we will use a simple conversion. So we have 100 kilometers per hour. Now to convert that to meters per second, we're going to multiply the top by 1,000, because to get from kilometers to meters you multiply it by 1,000, and we're going to divide by 3,600, since to get from hours to seconds you have to divide by 3,600 in this case because it's in the denominator. You actually multiply by 3,600 normally. Now once you look at this here, you can clearly see we have 10 over 36, which is 5 over 18. When you multiply these figures, we get a value of 27.7 meters per second. Now we have our final speed in meters per second. We can go ahead and address the second part of the question, which is to find the acceleration of the vehicle. Now we're going to assume the acceleration is constant. If we assume the acceleration is constant, that allows us to use our 4 equations of constant acceleration. This is one of them. V equals u plus at. The final speed, which is 27.7, is equal to the initial speed, which is 0 because it starts from rest, plus the acceleration, which is what we're looking for, multiplied by the time 4. You can see the quicker the vehicle, the shorter the time, the bigger the acceleration when you divide both sides by this number. In this particular case, we're going to divide both sides by 4, so we get 27.7 divided by 4, which gives you a value of 6.925 meters per second squared. So this is the value of the acceleration. Now we're going to go ahead and find the distance now in the next part. So again, we're going to use a constant acceleration equation. We're going to use s equals ut plus half at squared. You can probably use another equation as well. S equals u plus v over 2t, or v squared equals u squared plus 2as. You can use a whole array of equations. I'm going to use this one here. So we're going to say the distance is equal to 0 multiplied by the time plus a half multiplied by this acceleration here, 6.925 multiplied by 4 squared. Plug these numbers in and you get a value of 55.4 meters. Now the final part of the question asks us to state one modeling assumption we made about the acceleration in particular, and if you recall earlier on we said we're going to use constant acceleration. That allows us to use those 4 equations of constant acceleration, kinematics.